In this lecture, I am going to explain some important problems, numericals, the based on that Raoult's law. Okay. So here I am given one of the problems. Just read the question here. Here we are mixing the two liquids, liquid A and B, to form an ideal solution. So I am asking that vapor pressure of solution will be. Okay. So here, what is the information I am given? The vapor pressure of pure A, P naught A I am given. Vapor pressure of pure B, P naught B also I am given. And just 2 moles of liquid A and 3 moles of liquid B we are mixing. And I am asking that total vapor pressure of solution. So according to Raoult's law, here first you can write that given information. So what is the information I am given? P naught A is equals to 100 mmHg, P naught B 150 mmHg, and number of moles Na 2 moles, Nb 3 moles. Okay, so you know that here from Raoult's law, according to Raoult's law, what is the formula we have? P total is equals to Pa plus Pb. Otherwise, it is also possible to write P naught A XA plus P naught B XB. Okay, mole fraction of A, mole fraction of B. From that, mole fraction XA is equals to what we have the formula Na plus, okay, Na by Na plus Nb, number of. XB is equals to Nb by Na plus Nb. So this already you know that. So what is the Na? I am given that 2 Na plus Nb 5. Here XB is equals to 3 by 5. So already you know that P naught A and P naught B. So what is the value of P naught A? 100 into XA. XA is equals to 2 by 5 plus P naught B 150 into 3 by 5. Okay. So here what you get that? Do that simple calculation. So here you will get with respect to 22s are 40 plus 13 to 3 90. So total 130 mmHg. Okay. So just simple. We are given based on that Raoult's law. Okay. According to Raoult's law, P total is equals to Pa plus Pb. Otherwise, it is also possible to write. So P naught A XA plus P naught B XB. So which option is the correct? The second one is correct. Total vapor pressure is 130 mmHg. Now let's see one more. Here I am given one of the ideal solution, heptane and octane. Okay. So the vapor pressure of the two liquids I am given 105 kilopascal and 46 kilopascal respectively. Okay. So this is 105 kilopascal is of the heptane. So P naught heptane, vapor pressure of pure heptane is equals to 105 kilopascal. Okay, at the same time, the pure vapor pressure of octane, how much we are given? 46 kilopascal. Okay. So what we are asking here, we are asking about that P total, the vapor pressure of the solution I am asking. And at the same time, one more information also I am given. The weight of heptane, 25 grams, and weight of octane, okay, so much 35 grams we are given. So according to Raoult's law, if you want to calculate the P total, what is the formula we have? P total is equals to P naught A XA plus P naught B XB. Okay. So we are dealing with that ideal solution of heptane and octane. So that's why this formula I am writing in that P total is equals to P naught heptane, mole fraction of heptane plus P naught of octane and mole fraction of octane. Okay, the two liquids A and B just we are taken as an heptane and octane. So here to calculate the P total, you have the information of P naught heptane and P naught octane, but there is no information of X heptane and X octane. First, I would like to find out that X heptane. So what is the formula for the mole fraction? So the mole fraction is equals to the number of moles of particular substance by total number of moles. Is possible, right or not? So just I am written as a name. So the two liquids, what is that, heptane and octane is there. The mole fraction of heptane is equal to number of moles of heptane by total number of moles. So how we calculate? Okay, N heptane. So what is the formula? Number of moles is equal to weight by gram molecular weight. Weight by gram molecular weight. So what is the weight of heptane? Heptane weight is 25. Okay. So gram molecular weight of heptane C7H16. Okay. C7H16. How much you get that? You will get 100 gram molecular weight. So gram molecular weight is 100. So 25 by 100 nothing but 1 by 4. 1 by 4 is nothing but we'll take 0.25. That is the mole fraction of, okay, sorry, N heptane. That is the number of moles of heptane, 0.25. And similarly, what is the number of moles of octane? Number of moles of octane is equal to weight of octane by gram molecular weight of octane. So how much of I am given? That weight of octane is equal to 35. Okay. So gram molecular weight of octane C8H18. C8H18. There is a 14 units increases 114 gram molecular weight. 35 by 114 will get approximately 0.30. Okay. So here we got number of moles of heptane 0.25. Number of moles of octane 0.30. From here it is possible to calculate that X heptane. So how much you get that X heptane? That N heptane. N heptane is equal to 0.25 by N heptane plus N octane. You will get 0.55. Okay. So 0.25 by 0.55. You will get that approximately 0.45. Okay. 0.45. This is mole fraction of heptane. So what do you get that mole fraction of octane? So you know that 1 minus 0.45 will get 0.55. Okay. So now first I am calculated the mole fraction of heptane and mole fraction of octane. So now just simply substitute in this formula. You will get that P total. So what is that? P total is equals to P naught heptane. So P naught heptane already is there, 105. Okay. Mole fraction of heptane 0.45 plus here that P naught octane. So how much is there? 46. Okay. Into. So here mole fraction of octane 0.55. Okay. So you can do that. You will get that simply. Okay. So 72.55. 72.55 kilopascal. Okay. So here just simply first we are calculated a mole fraction of heptane and mole fraction of octane by using this information. So initially I calculated the number of moles of heptane and number of moles of octane. By using this I am calculated, and finally we are calculated according to the Raoult's law. Okay. So what is the vapor pressure of the solution? 72.55 kilopascal. Now let us see the next one. The very important model from Raoult's law. So here I am given that the vapor pressure of ethanol and methanols are 44 and 88 mmHg respectively. An ideal solution is formed at the same temperature by mixing 60 grams of ethanol with 40 grams of methanol. I am asking to calculate the total vapor pressure of the solution and the mole fraction of methanol in the vapor. So the important thing here when we are asking question regarding to that mole fraction, first you must be observe that they are asking in that vapor phase or liquid phase. Okay. So here you will get little confusion. So if you are dealing with that liquid phase, we are given that a mole fraction of A and mole fraction of B with XA and XB. Okay. So when I am dealing with that mole fraction in vapor phase, I represented with YA and YB. Okay. So that clearly I explained in that vapor pressure concept. Once you can go through that, you will get the clear cut idea. Okay. So first here I am writing that the given information, just you can observe that. The vapor pressure of pure ethanol, P0 ethanol, how much? 44 mmHg. And the vapor pressure of pure methanol, so how much we are given? 88 mmHg. 88 mmHg. And after that, I am given about that weight of ethanol C2H5OH. Just I am writing that formula. So weight of C2H5 60 grams and weight of methanol CH3OH how much? 40 grams. So what I am asking to calculate? I am asking to calculate the total vapor pressure. So P total is equals to, you know that already, P0 A X A. I am taking that P0 ethanol X ethanol X C2H5OH plus P0 CH3OH X CH3OH. So here we have information regarding vapor pressure of pure ethanol, vapor pressure of pure methanol. But here I have not mole fraction of ethanol and mole fraction of methanol. First I am calculating the mole fraction of ethanol C2H5OH is equals to number of moles of C2H5OH by total number of moles. So NCH3OH plus NC2H5OH and XCH3OH is equals to, so NCH3OH number of moles of methanol by total number of moles. Okay, so what is the formula we are using to calculate that number of moles? So number of moles of ethyl alcohol is equals to weight of ethyl alcohol by gram molecular weight of ethyl alcohol, molar mass of ethyl alcohol. So what is the molar mass of ethyl alcohol? First I am writing that molar mass of ethyl alcohol C2H5OH. Okay, so carbon 12 into 2 24, 24 plus 6 30 plus 16 46. Okay, and molar mass of methanol CH3OH. So what do you get that? Carbon 12 4 16 16 32. Okay, so what is the weight of C2H5OH? The weight we are given 60. Okay, 60 by 46. Okay, the molar mass of ethyl alcohol is 46 now. So 60 by 46. How much you get that? 1.3 approximately. You will get 1.3. Okay, so here I am giving the directly the simplification. Just you can take that. So at the same time, what do you get that number of moles of methanol? NCH3OH is equals to weight of CH3OH by molecular weight of CH3OH. So what is the weight? I am given 40 and molar mass of methanol is 32. 40 by 32, you will get that 1.25. Okay, so now we got number of moles of ethyl alcohol and number of moles of methyl alcohol. So now I am calculating XC2H5OH. First I am doing that XC2H5OH. So number of moles of ethyl alcohol, how much? 1.3 by 1.3 plus 1.25. Okay, 1.3 by 1.3 plus 1.25. So approximately you will get 0.5. Okay, here I am giving the direct. So just you can write on the 0.5. Okay, so exact if you need 0.510 mmHg. Okay, sorry, 0.510. The next, here the mole fraction of methanol XCH3OH. So here that number of moles of methanol 1.25 by 1.3 plus 1.25. So here the mole fraction of methanol, usually you get that 0.4893. 0.4893. So now we got mole fraction of ethyl alcohol and mole fraction of methanol. Now use this formula. P total is equals to, okay, so P naught C2H5OH. P total is equals to P naught C2H5OH. How much P naught C2H5OH? 44 into, okay, 44 into HC2H5OH 0.5 plus P naught CS3OH 88 into 0.4893. So here that P total you are getting that approximately that 65.52 mmHg. Okay, so this is total vapor pressure of solution. Total vapor pressure of solution. Here I am calculated the P total. Now let us see that mole fraction of methanol in the vapor. Okay, so one of the formula we have for any component, ith component, Pi is equals to Yi into P total. Okay, so this is the formula I am given. Okay, what is the Yi? The mole fraction of ith component in vapor phase. Okay, so what is the Pi? That vapor pressure of that ith compound. For example, now I am asking that mole fraction of methanol in the vapor. It is possible, right? PCH3OH is equals to YCH3OH into P total. Okay. So now we need the mole fraction of methanol in the vapor. Okay, YCH3OH nothing but the mole fraction of methanol in vapor phase. That is equals to PCH3OH by P total. So PCH3OH is nothing but it is possible, right? P naught CH3OH into XCH3OH by P total. So now you know that already P naught CH3OH. Okay, so methanol pure vapor pressure 88. Already you know that 88 into XCH3OH. How much we are that? 0.4893. 0.4893 by total vapor pressure. So 65.52. 65.52. So when you do that simplification by substituting all these, you will get that 0.6570. 0.6570. So this is the mole fraction. Okay, what is it is representing? This is the mole fraction of methanol CH3OH in vapor phase. Okay, so not in liquid phase, that you must be observed that. So this is a very important model. Okay, so that calculating of the total vapor pressure and the mole fraction of that component in vapor phase. Got it? Now let us see one more problem. So the vapor pressure of pure benzene at 88 degrees centigrade is 957 mm and that of toluene at the same temperature 379.5 mm. So the composition of benzene toluene mixture boiling at 88 degrees centigrade will be. Okay. So here one of the ideal solution we have taken, that is a mixture benzene and toluene. So the information is given from the question. So what is the information is given with respect to of vapor pressure of pure benzene, that nothing but P naught benzene. How much? 957 mmHg. And one more is given vapor pressure of pure toluene. How much? Is given as a 379.5. Okay. So what is asking? The composition of benzene and toluene. So is asking about that X benzene and X toluene. So he is asking that composition of benzene and toluene. According to Raoult's law, what is the formula? We have P total is equals to P naught A XA plus P naught B XB. Okay. So this is I am writing in terms of the benzene and toluene. P total is equals to P naught benzene okay, into X benzene, mole fraction of benzene, plus P naught toluene into X toluene. Okay. So from here, from the question we have the P total 760 mm of Hg and P naught benzene is there, P naught toluene is there. Okay. From the mole fraction, you know that the sum of mole fractions always equals to 1. Okay. For example, we have a solution with two liquids. Okay. So the sum of mole fraction of two liquids must be equals to 1. So I am using this information. From here it is possible to write XA is equals to 1 minus XB. Okay. So same like that, in place of X toluene, I am writing 1 minus X benzene. Okay. So here just you can observe that P total is equals to 760. P naught benzene is equals to 957 into X benzene. We don't know the value of this. Plus P naught toluene 379.5. So X toluene I am changing into that benzene 1 minus X benzene, the mole fraction of benzene. Is possible to write or not? Yes, we know that from the mole fraction the sum of mole fraction is always equals to 1. Okay. So here when we are doing that simplification, usually you get the value of X benzene. Okay. So if you do that, the simplification here you will get 0.66. X benzene is equals to 0.66. From here what you get that X toluene is equals to 1 minus 0.66, nothing but you will get 0.34. Okay. So why? Because we know that now X benzene plus X toluene equals to 1. So if you know the mole fraction of benzene, it is possible to find out the mole fraction of toluene. So based on this one, we are given. Okay. So what is the answer? The mole fraction of benzene is 0.66 and mole fraction of toluene is 0.34. So which option is correct? The first option is correct. Okay.